The concept of framing is how you present information to people will affect how they think about an issue. That idea is hardly new. It's probably as old as argumentation itself. But there was an influential study published in 1981 in the journal Science, which really changed how we think about framing. I'm going to tell you about that study. In this study, there was a hypothetical disease coming to America that was going to kill 600 people. And participants got to learn about a couple different potential government interventions and decide which one they liked more. First was intervention option A. According to that intervention, 200 people would be saved. That's option A. Option B was a little bit different. According to this option, there would be a 1 in 3 chance that everyone would be saved, and a 2 in 3 chance that no one would be saved. How do you think participants preferred these? Which option do you think they preferred more? I'll give you a moment to think about it. So, participants overwhelmingly preferred option A, where 200 people are saved, not the 1/3, 2/3 probability-based version. Now, that was half the participants in the study who looked at options A and B. There were another group of participants who considered some alternative interventions. First was option C, in which 400 people die. That's option C. And then there was option D, where there was a 1 in 3 chance no one dies, and a 2 in 3 chance everyone dies. What do you think participants chose here? I'll give you a moment. So again, the preferences were overwhelming, but it went the opposite direction. Here, 78% chose option D, where there was a 1 in 3 chance everyone doesn't die, or a 2 in 3 chance everyone dies. Why did the preferences shift so dramatically? Did you catch what was different about A and B versus C and D? If you didn't, go back and watch them again, but I'll tell you anyway. Options A and B were about the number of people saved versus not saved. Options C and D were about the number of people not dying or dying, right? You can describe the same outcome in terms of what stands to be gained in terms of lives saved or not saved, or in terms of loss, the number of people who won't die or will die. And this has been described in the literature as gains versus loss frames, and it's used, I think in the framing literature, it is the most commonly studied type of framing, or certainly among the most commonly studied types of framing. Now, why does this happen? Tversky and Kahneman, the authors of that 1981 study, developed a theory called prospect theory, which I think does a good job explaining why this happens. And I'm going to tell you about this theory by presenting a graph. On the horizontal axis are losses versus gains, and on the vertical axis is the value that people assign to losses and gains. So above the horizontal axis is positive value, and below the horizontal axis is negative value. And they've characterized the way, or this theory characterizes the way people evaluate gains and losses, and they follow curves kind of like this. With respect to the x-axis, both curves are concave. They start out steep, and then they start to level off with respect to the x-axis. And so the idea here is that the value of incremental gains or losses decreases. And we can think about this in terms of money. Let's say the horizontal axis corresponds to salary. Let's just focus on the gain side, because I don't think people have negative salaries. So on the gain side, let's imagine each tick represents $100,000. Let's say we're starting with a pretty good salary. So the value of earning $100,000 is quite substantial, right? The value quickly rises. $200,000, there's still an increase in value, but the relative increase is smaller. You get all the way up to the difference between $500,000 and $600,000 on the far right. That curve has started to level off. $600,000 is still better than $500,000, but the increase in value isn't nearly as much as it was going from 0 to 100,000. I think there's something intuitive there. And we can say the same about losses. Let's say instead of $100,000 in salary, let's say it's 100, each tick mark is $100, you lose. Maybe you had some money in your pocket and you dropped it. Well, that first $100 is going to hurt a lot. You could have lost $0, but now you've lost 100. Oh no, right? That sucks. Now, losing $600 is definitely the worst, but going from a $500 loss to a $600 loss doesn't hurt as much. Yes, losing $600 hurts more than losing $100, but the incremental pain of losing that extra $100 from 500 isn't as substantial. Does that make sense? I'm going to draw out that Tversky and Kahneman study about the government responses to the disease to make sense of why participants preferred option A or option D. So options A and B were presented in terms of gains, and we'll plot those out. So option A would save 200 people, right? And so we move over on the horizontal axis to 2 tick marks. We'll say each of those tick marks corresponds to 100 people. So 2 tick marks, and figure out where that curved line, where on the vertical axis is that point on the curve. And we see there's a value where A is. Now there's the option of saving everyone, right? So that's all 600 people, and we see up on the vertical axis where B intersects, right? But you remember there's only a 1 in 3 probability that all 600 will be saved. So we actually have to reduce B to there. B is actually lower than A. And so in terms of the number of people saved, option A is more valuable. Now let's look at the losses side, the number of people who die. So here's C. This is 400 people. That's option C, 400 people die, versus option D, it's everyone dies. But remember, it's a 2/3 probability. So we have to shift it up there to 2/3 of the way down. And what we see is that D is less valued, right? There's less value, but it's less negative value. So because D is actually further up, more toward the positive value, it is the preferred option. It's basically like saying something that the number of people dying will be somewhat less than 400, because that's what C represents, and D ends up being somewhat less than that. Now, the reason this happens, the reason that option D isn't simply equal to C, and the reason option B isn't simply equal to A, is because of the shapes of these curves. And I'll visualize this. What happens if instead of the blue curve and the red curve being curved, what happens if they're straight? You see everything lines up. Oh, and something I forgot to mention before, but that has become even more apparent here, is that the red line is steeper than the blue line. I didn't change that, but that's by design. I intentionally put that in. And there's a related idea that potential losses are valued more than potential gains. If somebody offers you a bet, I'll put my $10 against your $10, let's flip a coin, one of us will win. Most people will decline that bet because the potential loss of $10 is valued more than the potential gain of $10. So that's why the red line is steeper. Anyway, that was a bit of an aside. What I wanted to show here is that if the lines were straight, if there weren't these if value didn't diminish with each increment of gains or losses, then we would see something like this. Option A would be exactly equal to option B, option C would be exactly equal to option D, but that's not how people think. People think like this, and there's quite a bit of evidence showing that, and this has some implications for how communicators express risks. This was in the context of a disease. What is an appropriate response to a disease, and how that response is talked about in terms of gains or losses can dramatically shift people's preferences for one option or the other. Of course, this concept doesn't just apply to health risks. It applies quite broadly when people are evaluating risky options and solutions. I hope that was an interesting lesson on prospect theory. Thanks for watching.